Hi, Mike. Hi, Jean. I'm
Hi,
so
guys.
excited to be here. This is super exciting. I want to tell you first a little bit about Vertex, which you can learn more about at our virtual booth. We love the San Diego Science Festival of Engineering and Science. It's a really important opportunity for us to engage young learners and makes the next generation of science professionals. So at Vertex, we make medicine that makes people feel better. So we actually use chemistry and science to make medicines that change people's lives. And one of the things I want to talk to you about today is ice that doesn't melt. So, Mike, normal ice will melt and turn into a liquid. This, are you seeing it turn into a liquid when I warm it up? What's happening to it? Do we see any water forming? We don't, right? So, students or young people, I want you to think about what you're seeing and what kind of ice this is. It's a different kind of ice than water. This is carbon dioxide. So, I'm just going to show you. I have just sometimes I like to see things. So carbon dioxide, this is the word written, and this is kind of what the molecular structure looks like. If you're a chemist, you're going to write it down that way. Um, so I'm going to just work and play a little bit with this dry ice, which is carbon dioxide, and it's ice that doesn't melt because it goes straight from a solid to a gas. So that's what you're seeing. But first, I just want to think a little bit about lab safety. So in the learning lab, we always have our students wear goggles. I don't have goggles at home here in my kitchen, but I do have these glasses, so I'm going to put those on. The other thing I'm going to grab is not a lab coat, but I do have a really cool fleece that's going to just cover my arm. So I'm going to grab that. I'm also going to think about tying my hair back. I think really important when we're doing kitchen science. So students, if you're doing kitchen science, just take a few precautions. You know, you won't need it if everything goes right, but if something goes wrong, you'll be really glad that you covered up your body. Another thing I want to tell you a little bit about is closed-toed shoes. Got to wear closed-toed shoes when you work in the lab. Okay, let's get started. So I want to just speed up the process of it going into a solid to a gas. So I'm just gonna put it in some water. So this is a really cool glassware that they let me borrow and bring home. It's called an Erlenmeyer flask. So I'm going to just pour a little bit of regular water, this is just regular water, into this Erlenmeyer flask. I'm gonna take some of this carbon dioxide, this dry ice. This is what it looks like. I'm just gonna put it in front of the camera so you can see it. So you can see maybe it's sublimating. I'm just going to heat it up with my breath, which just heats it up a little bit. I'm going to put in here. What it's going to do when I put it in this water, it's just going to speed up the process. It warms it up. So it's going to sublimate faster. So hopefully you can see that gas forming. It's going to start to come out the top of this Erlenmeyer flask. And while we're waiting and talking about it, we're going to collect that gas. So we're going to collect it just like Jean did in a balloon. So she did it with a different process. She was creating carbon dioxide in a different way. So same idea. So I'm just going to try not to spill this. All right, that's just hanging out collecting gas, but I want to just talk about what we just saw. So when a solid turns into a gas, that's called sublimation. It's a very fancy word. It's called sublimation. And so it doesn't melt. It goes straight from a solid to a gas. So that's a really fun, cool thing about carbon dioxide. So solid carbon dioxide is also called dry ice. And it's called dry ice because it doesn't melt into a liquid. So if you leave this out, you're never going to see a pool of water. It's just going to go straight into the gas. So it's really super cool. That's why we love to use it in Halloween. We keep it on hand at Vertex because we need to sometimes keep cells and other things really, really cold. And so we keep it on hand at Vertex. Okay, couple of the cool things. So we learned about dry ice, why it's called dry ice. We learned a new word, sublimation, which is when something goes straight from a solid to a gas. Now we're collecting this carbon dioxide gas. So I want you to make a prediction. So if you're in a room with other people, I want you to predict what you think is going to happen here. I need you to actually stake your claim. What do you think is going to happen when I drop this balloon? This is a balloon full of carbon dioxide. It is not air. So I'm going to tie it off. So the question I have for you, and I really want you to decide, do you think it's going to float or do you think it's going to sink? Right? So A or B. So turn to your friend that's sitting next to you while you're watching this, or write it down somewhere because I want you to actually decide what you think is going to happen. All right, and then let's find
Wait,
out.
wait,
Ready?
wait. Gene and I
Go.
want to make a
Oh,
prediction. Gene,
okay. I would love that.
the balloon is full of carbon dioxide.
Yeah.
She's tied the balloon off. What's going to happen? She's going to drop it.
Float
Is
or
it going to
sink?
float or is it going to sink?
I mean, I think that it's going to float. Because I want it to float.
Carbon dioxide.
Because I want
it
it to
float,
save me.
But I think it's going to sink.
It's going to float.
I've seen balloons float before, so I don't think that's a crazy thing to say, right? We've seen lots
Right.
of balloons that are filled
Right.
with certain kinds of gases float.
Right.
Right.
So could be.
Okay.
And then we're going to talk after we find out what happens. We're going to talk about what it means about the gas.
What are
Okay,
other
so are we
things that
ready,
carbon
Mike? What'd
dioxide
you?
is used for? Like what's an everyday thing that carbon dioxide would be in?
I mean,
Carbon dioxide is. Yeah, go ahead.
I mean, it's a basic gas that we use all the time, right? We use it like that. That's how plants grow. That's the base of our food chain.
Okay. All right. Now
Yeah,
let's see.
and it's also in fire extinguishers, which we'll talk about in just a second.
Oh
you
my
know, and one of the
gosh.
reasons why it works in fire extinguishers is going to be one of the properties of it. So let's find out: float or sink. So we heard a float. I heard a couple different votes, but let's find out what happens. Ready? Oh, and it sank like almost like a rock, like really fast. So when we think about whether something floats or sinks, that has to do with something called density, which is a little bit like how heavy it is, but it's a little bit different. It's kind of how packed it is. And so the molecules of carbon dioxide are actually packed together more densely. They're packed in here. And so it actually has a more density than the air. And so it drops down. So that's why it sinks. Let's watch it one more time. Whoosh. Really fast. Okay, cool. So here we see our carbon dioxide gas. I'm going to just make a little bit more of this carbon dioxide gas, and then we're going to explore actually what Mike was talking about, asking what is a use for carbon dioxide. So a common use for carbon dioxide is that it will be a product in fire extinguishers. So when you spray fire extinguishers, one of the things that it might be spraying is some carbon dioxide. And so how does that work? So let's think about it. So we're just going to explore. So you probably know that a fire needs oxygen, right? So it really needs some oxygen that's coming from the air. We just talked about how carbon dioxide is more dense than that regular air. So I'm just going to take this can and put it over here for a second. And then I'm going to do something that I just love to do. It's so cool. So I can actually like pour this gas into this beaker. So check it out. And the reason that I'm able to pour it is because it's more dense. So it's collecting, you can't quite see. Oh, I got a little water. That was not my intention. All right. Kitchen science is not always perfect, folks. All right, I'm going to try and pour the gas and not pour the water. Let's see how it goes and see what happens to the candle. So hopefully you saw that all I did was pour that carbon dioxide gas onto this flame and it extinguished it. And so what happened was this more dense carbon dioxide gas that we saw in the balloon was more dense and drops. It actually pushes away the air that has the oxygen. And since that oxygen was required for the flame, it didn't work. So we're gonna do it one more time. All right, and just while I do it, I'm just gonna review some things we learned. So we learned a little bit about dry ice, that it sublimates. So it goes straight from a solid to a gas. So that's called sublimation. We learned that carbon dioxide is more dense than regular water. Than regular air, and that actually makes it sink when it's in a balloon and allows me to pour it from a vessel to a vessel. Fun fact, fluids are gases and liquids, so this is a fluid. All right, here we go. And we extinguish the gas, and I'm trying not to get wax on my computer. Cool. All right, so the last things I want you to know about carbon dioxide are that carbon dioxide levels are going up on Earth over time, right? And so one of the things that you can do about that is you can think about your transportation. So I made a little list here, so you can drive a hybrid or electric vehicle. You can walk or you can bike or you can take public transportation. So we really encourage you to do that. And at Vertex, we have all sorts of cool things that encourage our employees to take part in these sustainability measures. So really fun, great place to work. We have charging stations and bicycle racks, some things that you can do in your own life. Even if you're just a kid that doesn't make decisions about how you transport yourself all over, you can eat more veggies, right? Instead of having a burger, maybe have a veggie burger. That's really going to make a difference in the carbon dioxide levels on our climate change crisis. So other things you can do is recycle, compost, and try to reuse items. So I always use a reusable water bottle. So thinking about that.